Yo, year 10 and 11. Hope you're all well. So I'm going to go through the 3 mymaths tasks that you have set after yesterday's live lesson on indices and powers. Okay, there's 3 of them. The first one's pretty easy, the second one gets a bit juicy, and the third one is rock hard. Alright, so I'd like to see greens on all, please. The first one's pretty self-explanatory. The base numbers are the same, or the base letters are the same. If you're multiplying, you just add the powers. If you're dividing, you just subtract the powers. So for example, the answer to 2 to the 3 times 2 to the 4 would be 2 to the 7. Base number doesn't change, and you add these. This one here, the base is the letter A, and you would add the 3 and the 8 to get 11. Right, so that's very, very simple. Over here, the divides, here you subtract the powers. So 7 to the 5 divided by 7 to the 2 would be 7 cubed, or 7 to the 3, because 5 take away 2 is 3. Let's do a letter one. Let's do this one. The base is the letter G, and it's the power of 12 divided by the power of 8. You subtract them, and you would get G to the power 4. Right, so that's no problems. I'm not going to do all of them. Question 2. The first part of question 2 is power in a power. So as we spoke about in the lesson, when you power a power, you multiply the powers. So this one would be 4 to the power 9. The base stays the same. 3 times 3 is 9. Let's do an algebra one. Here the base is the letter A, and then you would do 7 times 4 to get 28. Right, so that's no problem there. A couple of tricky ones over here, so let's have a look at them. This one doesn't have a power, but of course it does. It has the power of 1. Right, so you've got to picture a little 1 there. So that's 15 to the power 7 divided by 15 to the power 1, which would be 15 to the power 6. Similar here, look, there's no power there. That means it has the power of 1. And 2 take away 1 is 1. So that's just e to the power 1. Here, there's no room for a power in the answer. I've got 8 to the power 9 divided by 8 to the power 8. 9 divided by 8, the powers of 9 divided by 8 would be 9 subtract 8, which is 1. So that's just the letter A. And hopefully now you've just realized I got this one wrong, because it's a multiply, not a divide. So that's 2 add 1, so that should be a power of 3. That was my deliberate mistake for this recording. Here, we spoke yesterday that anything to the power of 0 is 1. So this n to the 0 in the brackets has a numerical value of 1, and 1 cubed is 1 times 1 times 1, which is just 1. And for a combination, do the numerator first and then do the division. So x to the 7 times x to the 8, add the powers, that's x to the 15. So I've got x to the 15 divided by x to the 15. So I've got one thing divided by itself, so the answer to that would be 1. Okay? And I know I obviously didn't do all the ones on the left, but they are all correct. So that's indices task 1. Let's quickly go through indices task 2. This is mainly about negative indices on this page. So don't forget, a negative indice just produces a reciprocal. So 3 to the minus 8 is just the same as saying 1 over 3 to the power 8. X to the minus 9 is just the same as saying 1 over x to the power 9, and so on. Okay? And then reversing that process, giving you the expression as a fraction, as a reciprocated fraction, put it back into a negative indice. So this would just be 6 to the power of negative 6. This would just be u to the power of negative 1. And I'm sure you'd all agree 1 over v squared is just v to the power, if my keyboard can work, to the minus 2. Right? So these questions are the reverse of each other. Here you start with a negative and you turn it into the reciprocation. Here you start with the reciprocation, you put it back to the negative. These last ones here, rewrite these expressions, then work out a numerical answer. So rewrite them. So 4 to the power of minus 2 is 1 over 4 to the power of 2. 4 squared is 16. So So that's just 1 over 16. 3 to the power of minus 3 is 1 over 3 to the power of 3. 3 cubed is 27, so that's just 1 over 27. Right, so that's pretty easy, I hope. Let's mark it, check it didn't get any wrong. Woohoo, result. Right, let's look at question 2. This is the type of stuff you'd see at the start of a higher tier paper, non-calculator. Right, so straight away it looks, and you just got to take it one step at a time. So when you have multiple algebraic expressions with integers, just do the numbers first, as in, the 5 and the 8 here, the 9 and the 3. Do the integers at the start, then worry about the algebraic powers, right? So here I've just got 8 times 1. Most of you can do that. That's 8. And I've got x to the 6 times x to the 7. Add up the 6 and the 7, I get x to the 13. So you just got to take it one step at a time. Look at this one here. Forget about the letters a minute. Let's just look at these numbers at the front. 5 times 8 is 40. And then I've got e to the 6 times e to the minus 4. So already that's gone up a notch in difficulty. It's a multiply, so I add the powers. So I'm adding 6 and minus 4, which is the same as just saying 6 take away 4. So that's e to the 2. I will actually do them all, I think. Right, these ones here. Again, do the main integers first. 9 divided by 3 is 3. And then I've got a to the 8 divided by a to the 3. So you subtract the powers. These time, 8 take away 3 is 5. Here, 20 divided by 5 is 4. And then I've got c to the 3 divided by c to the 7. So I subtract those powers. 3 take away 7 is minus 4. Right, now this one's a bit trickier. Here, I've got to deal with this 2 being to the power of 4, right? So that means 2 times 2, there's my phone, times 2 times 2. It's Mr. Bones. So I'm just going to pause the video a minute. And we're back after my little chat with Mr. Bones there. Right, sorry, where were we? Okay, we were on this power of a power question. So the first thing I need to do is tackle the 2 to the power 4. So that's 2 times 2 times 2 times 2, which I think is 16. And then the m to the 4 to the power 4, again, you multiply those powers, which coincidentally is 16 again. Similar for this last one here, I will need to tackle the 3 squared to start, and 3 squared is 9. Then I tackle the n squared squared, and of course you multiply these powers to get n to the power 4. Right, so I'm pretty sure we did them correct. Let's have a look at these juicier ones over here. Right, again, tackle the integers first. So I'm scrambling for a calculator now because I can't do 15 times 16 at this time of day. So I'm on my phone. So I'm going to tackle the 15 times the 16 divided by 12 to start with. 15 times 16 divided by 12 comes out as 20. Of course, we all knew that, really. Now I'll tackle the letter r. So r cubed times r to the 11, add the powers, is r to the 14. And I'm dividing that by r to the 9, so I'm subtracting that then. So it's 14, take away 9, which is 5. Right? Just take a moment to digest that. I did 15 times 16 divided by 12 to get the 20. And I added these powers and subtracted this power to get the 5. Let's try this one here then. Right, 2 to the power 7 I got to tackle first. And then I've got to multiply that by 2 to the power of minus 1. Right, so that is 2 to the power of 6, isn't it? 2 to the power of 7 times 2 to the power of minus 1. Add those, 7 add minus 1 is 6. So that's 2 to the power 6. 2 times 2 times 2 times 2 times 2 times 2 is 64. Let's double check that. 2, 4, 8, 16, 32, 64. 6. Right, I think that's the 2 tackled. Let's tackle the s. So I've got s to the 4 to the 7, which is s to the power 28. Try and remember that. And I've got s to the 2 to the minus 1, which is s to the minus 2. So I've got s to the power of 28 times s to the power of minus 2. I need to add them. 28 plus minus 2 is 26. If that's right, it's a miracle. Obviously, I'm hoping when you do this, you'll be using a pen and paper and not trying to skip all the steps in your head like I'm doing here. Although I'm sure many of you could handle that, no problem at all. Right, let's have a look at this last one. Brackets first, let's follow bit mass, right? So let's tackle that 4 squared. That 4 squared is 16. 10 times 16 is 160, divided by 10 again is 16. Now let's tackle the t's. T squared squared is t to the 4. T to the 5 times t to the 4 is t to the 9. Divide that by t to the 6, subtract those, 9 take away 6 is 3. Is that correct? I'll take a green. Yes, chuffed. Right, okay. I mean, you're probably thinking I should have got them right, but it's early in the morning and I didn't use a pen and paper. Take your time on those. Use a pen and paper, especially on the more complex ones. Right, now the last one, Indices 3, is all about fractional powers. And just by looking at it, I'm thinking, blinking out, I probably should have a pen and paper handy here. But we'll give it a go. We'll give it a go and see what happens, okay? So when we spoke about fractional powers, we know that square root is a half, the 6th root is 1 over 6, the 4th root is 1 over 4, etc. Right? So the first lot shouldn't be that difficult. So the square root of a is just a to the power of a half. The 6th root of c is c to the power of a 6th. And I must say, because I set your manga high about half hour ago, which you'll be asked to do tomorrow, and that's all based on these fractional powers, and it's really good and it really helps with your understanding. So make sure tomorrow you have a crack at the manga high task on this as well. It's not published till tomorrow, so don't bother looking today. Right, this one here. So my 4th root is x to the power of a quarter, but my x is being cubed. So it's x to the power of 3/4. Take a second to digest that. Pretend that cubed was in there. I don't know why I'm touching the screen, you can't see that. I'm covering up the cubed with my finger, right? Pretend that was in there. The 4th root of x is just x to the 1 over 4. But I've got x cubed, so I replace that 1 with a 3 to get 3 over 4. Right, think of this. Pretend the 1 wasn't there and it was just the square root of e. That would be e to the power of a half. No problems, just like the one we did up there with the a. However, it's reciprocated, it's 1 over. So we know that means you have to give it a negative power or a negative indice. So I'm going to chuck a minus in up in front of that one there. Similarly, look at this, it's horrific. It's x. It's the 9th root, so it would be 1 over 9. But I got 5 powers of x, so it's 5 over 9. And it's reciprocated, so it's a negative power. So I chuck a minus in front of the 5. Right, so I'm pretty sure they are correct there. Now I'm going to mark them. Awesome. Obviously I haven't done these yet, so I'm going to go back and refresh this task and then do the right hand side. So I'm just going to pause the video for 1 sec.